Hello, welcome to my channel. Today I'll be talking about number theory and computation. This is episode 1 of a series of mathematical videos. Now, the reason why I decided to start with number theory is because everything we do in maths has to do with numbers. And numbers is very important because numbers are the bedrock of every mathematical calculations. So today I will start with the definition of number theory. Now, what is number theory? Number theory is a branch of mathematics that deals with the properties and relationship of numbers, and also it can be defined as the study of natural numbers and the integers. In today's video, I will be showing us set of different numbers with examples. Now we shall start with a set of natural numbers. Now, question, what are natural numbers? Natural numbers are the counting numbers and they form the basis from which other numbers may be built by extension, and the symbol for natural number is the capital N. Examples of natural numbers include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Next, we take a look at a set of whole numbers. Question, what are whole numbers? Whole numbers is a set of all natural numbers, including 0. That means that 0 and all the natural numbers make up whole numbers, and whole numbers are represented with the symbol W. Examples of whole numbers include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. The next, now we look at set of integers. Now, integers is a combination of whole numbers and natural numbers, or we can say it's a set of negative and positive natural numbers, including 0, and the symbol is Z. Examples of integers include negative numbers, 0, and positive natural numbers. So it can be negative 100, negative 99, negative 98, or negative 4, negative 3, negative 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5, and so on and so forth. Please note that in math or in science, when you see these 3 ellipses or these 3 dots, it means that there are some numbers preceding this first number here, and if you see it at the end, it means that there are some numbers that comes after this number here. All right, the next set of numbers are the rational numbers. Question, what are natural numbers? They are a set of whole numbers and integers, and the symbol is Q, letter Q. Examples of rational numbers are whole numbers, which include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Integers, just like we said earlier, they are the positive natural numbers and the negative natural numbers, including 0. So whole numbers and integers are all rational numbers. Next, we look at are different concepts that rational numbers can also include fractions, which can either be a terminating decimal or a recurring decimal. I will show us the difference between a terminating decimal or a recurring decimal. Examples of rational numbers. First, we have the terminating decimals. For instance, we have 1/4. It gives 0.25. This is called a terminating decimal because it does not reoccur. Again, we have 1/8, which is 0.125. As you can see, it ends. So these are examples of terminating decimal. For example, 1/4, 1/8, and 3/8, and so on and so forth. So a rational number can also be a fraction. The next type of rational numbers are the recurring decimals. For example, we have 2/3. It gives us 0.666666666. As you can see here, they are all repeated digits or patterns. Again, we have 1/3, which gives us 0.33333333. These are called recurring decimals, or you call them repeating digits. All these are examples of rational numbers. All right, let's go to our next numbers, which is the irrational numbers. These are just an opposite of rational numbers, and they are numbers that cannot be expressed by an integer or the ratio of two integers. In other words, irrational numbers cannot be expressed as a fraction. All right, they are expressible only as decimal fractions, where the digit continues forever but with no repeating patterns. All right, now the symbol for irrational number is Q prime. Yes, in math, when you see superscript on a letter, it means prime. So this is the symbol for irrational numbers. Examples of irrational numbers, we have, for example, we have 22/7, which gives us 3.14285714, and it continues. As you can see here, all these are non-repeating patterns. As you can see, they are non-repeating patterns. The numbers does not repeat, so they are non-repeating patterns. √2, √3, √99, these are some examples of irrational numbers. I'll show us the last set of numbers, which is called the set of real numbers. Now guys, all numbers, rational numbers and irrational numbers are regarded as real numbers. That means natural numbers, whole numbers, integers, rational numbers, they are all regarded as real number. And the symbol for real number is given as capital letter R. Now question, what is or what are the examples of real numbers? Can you guess? Wow. The examples of real numbers is this. Any number you can think of. Is it -1, -2? Any number you can think of is a real number. So these are the set of numbers that I have explained. In my next class, I will start going into some calculations. So subscribe to this channel for more maths videos. I'll be using different curriculums. I'll be using curriculums in the Caribbean. I'll be using curriculums in West Africa. So if you are in this region, subscribe to this channel for math videos for your Csec, for your CAPE, for your JSC, for your WAec, for your SSC, for your Jamb, and for your JSCCE. For all your math videos, if you have questions, feel free to leave it in the comment box below and I will respond to you as soon as possible. Thanks very much for watching. God bless you. See you next week. Bye bye.